Hello, this is the screencast for 4.1. I apologize, my Wi-Fi's out, so I have to use my phone hotspot to upload it. Can't go to school because I don't feel well, so this sucks. An important skill, so here we go. Here's the first lesson. Hopefully this will be short. We'll have plenty of time for questions later. I just want you guys to take this in bite-sized pieces. You can pause the video if you have questions and then be like, yo, Miss O'Brien, later. Be like, at this point. That way we can go over everything that you don't understand. So this is a slide that I made for today. And this was the intro, like a general lead-in. So important skill in calculus is able to decompose a function into two simpler functions. So for instance, if we have fog and goth, we're literally having a function inside of another, right? F of g of x. We plugged in that whole g of x function inside of f. Okay, so, if we have something like, h of x equals 3x minus 1 squared, then I could write this as, okay, the 3x minus 1, I could say is g of x, and this x squared, let me pick a different color, and this x squared is the outside portion. I'm literally taking f of g of x, right? Because I'm plugging g of x into f of x. So decomposing it, right? We got to identify the function that's within another one. So there's two examples here, right? I have 1 over x plus 2 squared. So let's find two functions, one that's like outside and one that's inside. So having this ability will make this section way easier. So identify, if I'm trying to write this as f of g of x, I'm going to write them in two different colors again. I would like to know what function is inside of another. So I notice that this x plus 2 is inside a square. So if I let g of x equal x plus 2, okay, that means that f of x is 1 over x squared. Okay, because think about what happens, right? If I plug in g of x inside of f of x, I would have, right, f of g of x. This is the same thing as saying like fog of x. So I'm plugging, let's see, 1 over x squared when I'm plugging in my g of x function, x plus 2, into x squared. So that's what it turns into. Okay, so this we're decomposing, that is what I'm looking for. And then in the second example, right, I see that I'm plugging in 5x plus 2. I'll have that be my g of x because they defined it as my inside function, the one that's being plugged in. And then the outside function is going to be f of x equals absolute value of x minus 3. Right? Imagine if I plugged g of x into f of x, right? So wherever there's an x, I plug in 5x plus 2. Okay, so you get the point. This helps us when we're trying to differentiate things like sine of x squared minus 4, because individually you know how to take the derivative of sine. You know how to take the derivative of x squared minus 4. But what happens if I have a function inside a function? So I'm not just taking sine of x, I'm taking sine of x squared minus 4. So the answer is a chain rule, and it's probably the most widely used differentiation rule in mathematics. It was difficult to find, a variety of problems in the last chapter that you could be able to do that were available online because this is used so often. Okay, so what the heck is the chain rule? So the chain rule, basically, we're taking the fact that we can have a composition of a function. We can have one function inside another. And so the rule is work from the outside in. Right? So the derivative of a composition function is the derivative of the outside times the derivative of the inside. Notice we didn't change the inside at first. So you're working from the outside in. So this is Newtonian, and then in Leibniz notation, you could say, okay, so I'm taking dy du times du df, and what the heck is this u? Okay, I can rewrite my function in terms of u. I'm using u substitution, which you learned in Algebra 2. Yes, and pre-calculus, sorry. I forget what class I'm in sometimes. So notice that dy dx is literally the derivative of the outside times the derivative of the inside. So if I had something like, let's do an example, right? Sine of x squared minus 4. So we can I'm going to let u equal x squared minus 4. That way, now I'm just taking sine of u. And we know what sine of u is. Sine of u is cosine of u. And then once I deal with that, I'm like, okay, so then I take the derivative of whatever the inside is. So what is the derivative of u? Well, what's the derivative of x squared minus 4? It's going to be 2x. So we multiply these together. And notice it's cosine of u, so I have to plug back in the original one. Okay, so following these rules, dy du is the derivative of sine of u. Okay, so sine of u is cosine of u times the derivative of u with respect to x, so that is going to be times 2x. But we can't leave it in terms of u, so I have to plug this in. So it's going to be 2x cosine of x squared minus 4. So at first, I left the inside alone, and I only took the derivative of the outside. Then I took the derivative of the inside, and I just wrote it all out. So, that's a little confusing. Let's go over a couple more examples. So here we're going to use substitution and chain rule to find dy dx. So cosine of x squared minus 1. We're going to let u be x squared minus 1. So I'm going to rewrite my function. So we have, dy dx is equal, I want to write in a different color. So dy dx, I'm just going to write it in terms of u dy dx is equal to dy du times du dx. And one thing I want you to note is this is not just like simple algebra. You can't just like cross out the du, right? It doesn't work that way. Okay, so let's rewrite it. So I'm going to let y equal cosine of u, because we already said u is x squared minus 1. That is the inside function, inside of cosine. So now if I take the derivative, so dy du is going to be negative sine of u. And remember, u is x squared minus 1, so we'll plug that in later. We know that u is x squared minus 1, so du dx, I should do that in a different color. Let's do this. Du dx is going to equal 2x. So plug all that in. So we know dy du is negative sine of u. Well, u is x squared minus 1. And then times du dx, so that's times 2x. So this is what dy dx is equal to. But I would rather write it in a different way. I'd rather write the negative 2x, so that coefficient out front, and then say sine of x squared minus 1. Okay, we'll try the next one. So here I'm identifying what the inside function is, right? Sine is my outer function, root x is my inner function. So the derivative is literally going to be the outer function's derivative times the inner function's derivative. Okay, let's see. So we have y prime is equal to, the derivative of sine is cosine. So cosine, I leave whatever's inside alone, times the derivative of root x. So the derivative of root x, so if we have root x is the same thing as x to the 1/2 power. Okay, so if I want to, let's see, take the derivative with respect to x of x to the 1/2 power, we're going to use power rule for a rational exponent. So subtract 1 on the exponent and multiply by your new, multiply by your old exponent, subtract 1 on the exponent. So this is just 1 over 2 root x. Okay, because 1/2 is 1 over 2 times, let's see, x to the 1/2 is literally 1 over x to the 1/2, and 1/2 is just same thing as square root. So this is times 1 over 2 root x. So y prime is going to be cosine of root x all over 2 root x. All right, an object moves along the x-axis, so its position at any time t is greater than or equal to 0 is given by x of t equals cosine of t squared plus 1. Find the velocity of the object as a function of t. So we have position, right? What we need is velocity. Well, we know how to do that. We just have to find the derivative. So right here we have x of t is equal to cosine of t squared plus 1. Awesome. So the outside function is cosine. So this is the outer, this is the inner. So first it's kind of like you're peeling away layers of a orange, or those old babushka Russian dolls so you work your way from the outside in. Or it's like an onion, right? You got to peel the outside layer before you get to the inner. So let's see, v of t is the derivative of position, so that's why I have that little prime. So first the outer function, so x prime of t. Derivative of cosine is negative sine. Leave what's inside. Now take the derivative of t squared plus 1. So it's going to be times 2t. So v of t is equal to negative 2t sine of t squared plus 1. All right, so it's inside out rule. This is what I've been talking about. This is the way I prefer to write it. So you're literally peeling an onion. First, you're working on the outside, taking the derivative of the outside function, and then you multiply by the derivative of the inside. And you leave, like you always leave whatever's inside. You peel one function away, one level of complexity at a time. So here I have cosine of 3x. So this time, I'm not going to use u substitution. Y prime, so I'm going to take derivative of cosine, right? So I'm using the outside portion first. Derivative is negative sine. And I have to leave whatever's inside alone. Now, I'm going to take the derivative of 3x. The derivative of 3x is 3. Multiply by it. So to write out the final answer, it's going to be y prime is equal to, let's see, negative times, this is just a multiplication, so negative 3 sine of 3x. Okay, remember working from the outside in, so I'm going to color code again. So I'm going to take the derivative of the outside first. Y prime, derivative of sine is cosine, and then I'm leaving what's inside alone, because I already took derivative of the outside, right? Peeling one layer of the onion at a time. Now, take the derivative of the inside. Okay, so this is just going to be 2x plus 1. And let's see, to rewrite it, I just prefer having, my x's, the x's that are alone out front, and then having my trig functions in terms of exponents. This is the way I prefer to write it, because that way I don't miss that 2x plus 1. All right, and then this is the last example of today's notes. So repeated use of chain rule. Sometimes we have to use chain rule 2 or more times to find a derivative. You just go chain, 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 right? You just follow the links in the chain. So the first one is I'm going to take the derivative of tangent, because this is a very outside function. So we know that this is the very, very outside. So the derivative of tangent is, okay, so let's see, y prime is secant squared of everything that's inside. Okay, so secant squared, and then I have 5 minus sine 2t. Okay, now let's take the derivative of all of this stuff, right? 5 minus sine of 2t. So I'm going to multiply by, let's see, the derivative of 5 is 0, so derivative of negative sine is negative cosine, but check this out. We have 2t in here. So that itself is another layer of complexity. So I'm taking cosine of 2t, so I'm writing it in black so you can see, I have a whole nother function I have to multiply by. So then multiply by the derivative of 2t, which is 2. All right, so we had 3 layers to this onion. We had the tangent function, and inside that we had 5 minus a sine, and inside sine we had 2t. So putting this all together, y prime is going to be negative 2. I like writing it in terms of least exponent to greatest, so negative 2 cosine of 2t times secant squared of 5 minus sine of 2t. And that's all we're going to be doing today, right? We're taking 3 days to learn the chain rule. We're going to do some review next class. Hope you guys have a good Thanksgiving break.